Solving simultaneous linear equations, example 5. 50, 20 and 10-cent coins are collected from a coin machine and counted. The total value of the coins is 32 euros. When counting, the cashier noted that twice the number of 20-cent coins added to the number of 10-cent coins equaled 3 times the number of 50-cent coins. She then noticed that 4 times the number of 50-cent coins added to the number of 10-cent coins equals 6 times the number of 20-cent coins. We'll define the number of each type of coin in the machine. Okay, firstly, let's name our variables. We're going to let A equal the number of 50-cent coins, B the number of 20-cent, and C the number of 10-cent coins. We are going to create 3 equations with these 3 letters. The total value of coins is 32 euros, or 3,200 cents, since we're all dealing in cents here. The value of the 50-cent coins would be 50 times A, 50 cent multiplied by the amount of coins. 20B is the value of the 20-cent coins, and 10 times C the value of the 10-cent coins. So that must be equal to this 32 euros, or 3,200 cents. 10 divides across the whole way, giving us an equation that 5A plus 2B plus C equals 320. So this is our first equation. We also know that twice the number of 20-cent coins added to the number of 10-cent coins equals 3 times the number of 50-cent coins. So twice the 20-cent coins, that will be 2B, added to the 10-cent coin number, that's plus C, equals 3 times the number of 50-cent coins, 3 times A. And just manipulating this formula, if I take 2B and take C from both sides, I have 3A minus 2B minus C is equal to 0. That's our second equation. We know that 4 times the number of 50-cent coins added to the number of 10-cent coins equals 6 times the number of 20-cent coins. Now 4 times the 50-cent coins, that's 4A. Added to 10-cent coins, that's plus C, equals 6 times the 20-cent coins, 6B. Again, I'm going to write this in terms of A, B and C, so I'm going to take 6B from both sides, giving that 4A minus 6B plus C is equal to 0. So now we have 3 equations with 3 variables, so we should be able to solve these. I'm going to label the equations A, B and C. We're going to use elimination. I think the easiest thing to eliminate would be C. So if I write down equation A and add it to equation B, we'll see the C's will cancel out. So equation A plus equation B we see that we have a plus C and a minus C, so the C's cancel out. But we also have the B's cancelling out here. We have a 2B minus 2B, and this is really useful. So we have an equation that 8A is equal to 320, giving us that A is equal to 320 divided by 8, which is 40. So the number of 50-cent coins is 40. Now, if I take equation B and add it to equation C, again, we'll have the C's cancelling out or being eliminated. They'll add together to be 0. So when I add this, the C's are eliminated. I have 3A and 4A, that's 7A. Negative 2B, negative 6B, that's negative 8B is equal to 0. So manipulating this and subbing in that we know A is equal to 40, we end up that B is equal to 35. So the number of 20-cent coins is 35. Now if I take our A and B values then and sub it back into equation B, this may be the easiest of the equations. So equation B, to rewrite it, I could have C is equal to 3A minus 2B. So that would be 3 40s minus 2 35s. And this works out to be 50. it would be good in terms of the context of the question just to make it clear exactly what we're saying these numbers stand for. So I'm going to say 40 is a number of 50-cent coins. 35 is the number of 20-cent coins. And 50 is the number of 10-cent coins.